So I guess I'll do my own intro. My name is Eric Schmidt, and I gotta remember to see all of you, because there's more of you on the screen, so I apologize. I don't mean to ignore your existence. But my name is Eric Schmidt. As I just said, I'm a high school teacher. I teach at the Dublin School over near Peterborough, New Hampshire, in Dublin, New Hampshire, more specifically. And I teach in a bunch of tech classes, whatever needs doing at that particular time. And please forgive my voice being a little hoarse, because today was our first day back after winter break, so after 3 very quiet and calming and relaxing weeks of very little talking, I returned to yelling over teenagers. So my voice is a little tired, please forgive me. So my plan for tonight is going to be a little bit of a mix. So normally our meetings, we have somebody come up and we talk at you for a while, and we have some Q&A mixed in there too, about some space stuff. And my goal tonight is going to be something a little different, in that I'm going to treat you like my students. Is that okay with everybody? But thankfully, I shouldn't have to yell over you as much. I'd like this to be more of a discussion rather than me talking at you, though I'm going to do a bit of that as well. So Zoom people. Margot is currently trying to get logged in on a different laptop, and so if you prefer to type, she's going to read your questions out so that everybody in here can hear you. We have somebody in the waiting room. Thank you. Okay. So, but here's the thing, is that everybody in here, in the physical space, can hear all of you people on Zoom, and could the people in the space make your presence known to the virtual people?
Hello! Hello!
Can you hear all of them? Give me thumbs. Cool. So even though you're not here and they're here, and relatively speaking, you're where you are and they're not where you are, we can all communicate with each other, and this is how this is going to work. So what I'm going to say is, please participate. You don't have to. If you're the quiet person who would rather be passive and just listen, that's okay too. But please, don't wait for me to call on you because you're tiny. Y'all just do what you got to do. Yes. Except you. Except you I have to call on because you have... oh, admit you. I have to let the person running the meeting in the meeting. There you go. Normally I ask you. All right. Oops. We almost made somebody who's not part of it. Oh, somebody else got it. Okay, perfect. Cool. All right. So, this is going to be a little bit abbreviated. Essentially what I'm going to do for you all today is a very highly condensed, highly compressed version of a lesson that I spend about a week on with teenagers, with juniors and seniors primarily, a couple sophomores, about some philosophical implications, because at the high school level, at least in the kind of classes I teach, we're not going to be doing field equations or college math. I'm not qualified. You might notice I have no letters after my name. Please take everything I say with a boulder of salt in that regard. But it's really good to start thinking about it and apparently moving over. Keep going. I'm just going to move y'all. And so what I'm going to do is I'm going to set up a bit of a question for y'all. I want to get some definitions, and this is where I want to hear from you. This is, you have an upfront, you have a front-heavy job tonight. And then I'm going to talk some physics. Please raise your hands, both in meet space and in the virtual space, if you have taken any kind of physics or studied physics in any serious, formal or informal way since high school. Okay.
We have some hands.
Anybody with physics-related letters?
I took physics 3 times in college.
All right. So, for any among you who are highly trained or highly studied on this, I need to apologize in advance. You're going to be mad at me. And the reason you're going to be mad at me is I'm compressing this down so much, and we're already running a little late. I'm going to gloss over a lot and leave out a lot, and it's going to make you mad. Please forgive me. But however, my goal is I want to raise some questions. I want to get you chewing on this, and I want you to kind of be so interested and curious that you're going to Google it later, and then send me an angry email about all the cool stuff that I forgot. Not that I didn't forget, I might have forgotten it, but I didn't say it. Right? So I'm going to teach you a little bit of the physics, and then I want to return back. And my hope is that you all argue in a productive and fun way with each other and me. So the first thing I want to start with is we need to define some terms. And give me a, we all good on Zoom still? Cool, all right. So we're going to start with the philosophy, please. I'm glad you're all virtual because you can't throw anything at me. So, and also by the way, I have the worst spelling. Determine versus I have the worst handwriting and drawing skills of anybody on my campus. The joke is that they should have given me a medical degree upon seeing a handwriting sample. So I apologize. So I'm going to say it really loud as well. So I want you all to come up with a definition of if I say determinism, as in the future is determined. Whatever is going to happen is going to happen whether you like it or not, versus whether you have free will. Have I chosen to almost drop the marker? Or was the initial conditions of the beginning of the universe set particles into motion such that there was no possible event that could have occurred at that particular moment and this moment as well, where I dropped the marker? Did I make a choice or did I not? I want you to expand on your definitions. When you hear determinism, what do you hear? That's what I'm going to start you off with. When you say free will, what do you hear? And this is where it's your turn, so please help me.
So determinism is essentially a very long string of dominoes, the first one of which got tipped over at some point, and none of the dominoes have any choice but to fall when hit.
Okay. Everybody give me a thumbs up on Zoom if you heard that. That was Rick.
It's coming through.
Okay, what Rick had to say was, his definition of determinism is that a set of dominoes was placed, please correct me if I'm paraphrasing this incorrectly, and once set upon, they will fall. Because that's what, this has to happen. The dominoes begin to fall one after another. You have a string of causality.
Have no choice.
They have no choice. They get hit with the previous domino, they will fall. They
The
have no
cosmic
say in that.
Rube Goldberg machine.
Cosmic Rube Goldberg machine from Canada.
You know, that kind of fits the situation.
Doesn't it?
No, Rube Goldberg machines generally work by the time they go on the internet and get broadcast on TV. So, Zoom people, it's your turn. Somebody take one for the team. Help us out.
Okay, I have a question.
Go for it.
Okay, the universe is deterministic on a large scale, such as the solar system. We know exactly the phases of the moon, how the planets are orbiting, where they're going to be in the sky, how the constellations move. All that is very deterministic. Okay, so Einstein's theories are more deterministic because they deal with gravity and the large-scale universe. And when you deal with the quantum world, that all falls apart.
Yeah, don't say that word yet.
Don't spoil the fun. But
Yeah. No, if we just do QM here in big letters, it kind of breaks what I'm setting up for you. But we're gonna get there. We're gonna get there. But yes. So somebody, preferably on Zoom, but I'm not gonna exclude anybody here if you got an idea. We talked a bit about this. Give me some here. What does that really mean? What do we mean when we say free will? What are we talking about? What does that require? What does that imply? Go for it.
I would say that nothing has been predetermined, that you made the choice to drop the marker when you made the choice to drop the marker moments before, and there's nothing that came before or after that necessarily determined that you would have to do that. So it was your own free will that allowed you to do that.
Okay. Could I ask you or somebody else to elaborate by what you mean by choice? What is a choice? What is a decision?
You could have done something else.
Could have done something else.
Multiple
I
possible
forget your name.
outcomes.
John. So John's added, could have done something else, Kevin, you said?
Multiple possible outcomes.
Multiple possible outcomes that I can do something active. I have an active agent role in choosing which one of those outcomes I want based on no previous dominoes. No dominoes can tell me whether I drop the marker or not. We feeling satisfied with that? We got some good working definitions. Zoom people, thumbs up, thumbs sideways, thumbs down. Are we happy with these definitions for now? We can operationalize them, move forward. Cool. All right. So, this board is very shaky. All right. It's going to get worse.
Hold on.
I'll draw in big, horrible capital letters to try to make this more.
God, the lines aren't even straight.
You didn't have any choice.
You're gonna treat us like high school kids.
Now hold on. Was it determined that this would lean slightly to the right, or did they make a choice that it would be slightly to the right? Or do I have no choice about it because I'm terrible at drawing?
If I actually wanted the answer for this, I would have you do this every day for 10 years and then look at the results.
And the writing will get worse and worse.
So, all right. What do these mean? What are we talking about when we talk about this? So past, present, and future. We have a pretty, we probably believe we have a pretty intuitive understanding of this, but let's define it. Let's get the words out there. In-person Zoom, whoever speaks up first, it's yours. Let's start with past. When we say the past, what do we mean?
They're markers in our present timeline, I suppose.
Wait, you snuck in an extra word though.
Oh, sorry. In the timeline that we are currently experiencing, I guess we all know the time depends on the observer, right? So, but it passes every moment before this one, present is this moment, future is moments that are to come. But that all depends, of course, on who's observing, who's talking about.
Okay, so you raise an interesting point. I'm going to ask. Go
We've
for it.
got a comment in the chat.
Oh, a chat question? What comment?
Christine Diorio, I apologize if I mispronounced your last name, that there's another way to think of determinism, which is the entire book of time that we only see one quote-unquote page of at once, actually being equally present in some other sense. In other words, the past, present, and future being equally real and bound to each other.
Okay. So this is the point at which my students generally reference was Fahrenheit 451. You all remember that book?
No.
The Tralfamadorians? I forget. But the aliens that see different moments in their timeline all simultaneously.
Slaughterhouse 5.
Slaughterhouse 5. I'm sorry, not Fahrenheit 451. I apologize.
Trouble.
That just got broadcast. That just got broadcast. Dude.
Sci-fi novels with words and numbers in their
Edit
names.
that out, please. So,
Did you intend to do that?
no, that was a domino. All right, so that was actually pretty good. It hit all three of them here. I'm going to add a little bit of an elaboration, and I want you to ask yourselves quietly this question. When you talk about the past, do you say or think the past or your past? And is there a difference? And then by extension, the present or your present, or the future or your future. What do you do? Raise your hands, both in Zoom if you're willing and in person, if you think of the past as some absolute thing that we all share equally. It is the past. That's it. Beyond. Raise your hands if you think it's your past. This is not narcissism, I promise. You might just know what reference frames are. It's okay. But your past. Who does that?
Do you mean our understanding of the past or the actuality?
I'm talking about a definition. When you think of what this means, are you thinking, did you have a past before you were born? That might be another question, a way to ask it.
Did I?
Was there a past before you were born?
Oh, yes, but I wasn't part of it.
But you weren't part of it, so was it your past? You see what I'm getting at? It's a little bit of a delineation. It's about an observer. And if the observer didn't exist yet, it's kind of weird to talk about that observer's past because it's a thing that doesn't exist yet. But this is I'm using this as a wedge to get you to think a little bit more reference framing. Yes?
What I wanted to say with that subjectivity brought into it was that in terms of experience, all we ever experience is the present, but certain parts of it are further away from us than others.
Yeah? The Zoom people, did you hear that? Kevin added that all we ever experience is the past, is the present, but what was the second half?
Some parts are farther away than others.
Some parts are farther away than others. Margot?
I would then question, what does it mean to experience something? Because I can close my eyes and I can remember something, or I can close my eyes and I can imagine something, and I can experience the past or an imagined future.
Well, at that point, you're talking about consciousness, and we've wandered away from physics completely.
Have we, though?
No. We're starting 20 minutes late. I'm gonna redirect us back on.
Just what a domino works.
Yeah, consciousness is when people build CPUs in Minecraft, just get the whole circuitry reproduced one layer down. Everything is physics if you scale up enough.
All right.
Turtles all the way down.
Oh boy. All right, everybody recognize this?
From first grade.
One-dimensional graph, also known as a line segment.
Scar with stitches.
Okay.
Centipede.
So we're gonna call this T for time, right? And we understand that if we're at this one, whatever number that is, we consider things that are less than, that are of a previous, a lower number on the time coordinate, if we're thinking that way, as the past. And this infinitesimally itty-bitty tiny, like now, right? It is constantly evolving, very hard to define, not really good to plug into mathematical equations. That's the present, and then everything after that, literally everything after that, we have somebody in the waiting room, is the future. Now, I'm transitioning us to a mathematical description of it. That is, it is what direction from us on the time axis are we talking about? If it's something that happened over here, we call that the past. If it's something that happened over here, we call that the future. And because time goes, for reasons that are entirely clear to us, yes?
You didn't make me co-host.
I didn't make you go.
You made the other Twitter.
I made the other severe co-host.
As it was always going to be from the moment of the Big Bang.
Okay. The real Silvera is now co-host, but I'm getting them all anyway. All right. So, does this make sense? I'm making a little bit of a transition, and I'm going a little speedier than I wanted to save some time, but does this transition make sense? Now we're defining this as a time coordinate now.
You made a choice to talk about the future using a term similar to what will happen rather than what may happen.
Yes.
And that's
I'm going to call the domino on that one.
okay. All right.
But it's good that you keep and hold that, because it's good to keep me on my toes with that, and we're going to need that in a minute.
I think what you just drew was a deterministic timeline. I think a free will timeline would look more like a rail yard.
Is that better?
Branching paths.
Yeah.
I was
paths.
going to do parallel lines, but yeah, a big piece of lint.
We got to get some Feynman in there. It's good.
Is it always linear? I mean, do we know?
Fractal.
Yeah, I love that you're analyzing this that tightly, and I
mean,
totally
some
didn't.
diagrams aren't linear, but
I
you
totally-
stylize it for benefit.
I totally didn't mean that to be taken that, but this is awesome. I love this. So, all right. So I'm going to move us to one more definition, and that is an event. Does anybody know? This is a little bit more physicsy in the context that I'm looking for, but I don't need you to answer in a physics sense. I want you to answer with what you have in your brain. What is an event? What is an event? A happening. How do we define
a
it?
description of the contents of a segment of time.
Contents of a segment of time.
A
Okay.
change.
Kevin says a change. The word I like to use is interaction, which requires a change, I would say. And
In a context of time.
it has to happen at a time. Zoom, anybody want to jump in? How we would define an event?
It has to happen at a place.
At place. Yes, you see where I'm going. So, anybody, before I just run with that, anybody else want to add anything? Okay, cool, we'll run with that then. So, yes, an event, in the context that we're going to talk about it tonight, is a thing that happens. Now, already I've imported a lot of stuff that's mixed in with our language, but it has to happen somewhere, sometime, right? And so we do this, we live in a 3+1 dimensional universe, so we do this by defining its x, y, and z coordinates, right? Where did it happen? In the 3 spatial dimensions, you need 3 coordinates to say where you are, even if they're leaning. And then because the +1, when did it happen?
We have a comment in the chat again
A
from
chat
Christine.
comment, okay?
Faulkner once said, "The past is never dead, it's not even past."
Hold on to that. You're going to be able to use that in a minute. Oh, wow, I'm really leaning. Sorry about that, folks. I'm not used to this shape of whiteboard. All right, so we have 4 coordinates, 3 spatial, right? Left to right, forward, back, up, down, and that took time. And so the t kept changing whether I liked it to or not, because that just seems to be the way things work, and we haven't been able to mess with that yet. So If something happens somewhere at no time, did it happen? Is it happening or would it happen? I'll repeat that. If something happens somewhere, but at no time, past, present, or future, did it, is it, or will it happen?
It did.
If it happened at no point in time?
Or we wouldn't be having this conversation.
So is it an event if it happens somewhere, never? Or no when?
Well, are you suggesting that time existed before the Big Bang?
No, I'm not going there. I'm asking a question of, Rick, if you had $1 billion in your bank account for 0 seconds, were you ever rich?
How fast did he click by? I would like to ask you a question that might help.
Cool.
What if this event that didn't happen at any time, I guess I'm chasing a circle. I was going to say, what if it happened after everything else, or before everything else?
By saying before and after, you're already importing temporal, which means you're already talking about a time coordinate because you need a point of comparison.
All right, let me ask you another question. If we don't know when it happened, or if it happened at no time, can we know that it didn't happen?
I'm going to put that one back to the audience. If we don't know when it happened, do we know if it happened?
Can you prove that Rick didn't have $1 billion for the shortest?
Oh, that's a shifting of the burden of proof fallacy there, Kevin. Come on.
Yeah, so-
It's up to Rick to convince us that he had $1 billion so that he can buy something.
No, it's up to me to convince the tax people.
One of the problems I'm having with this is whether time, so we were talking about, is the past something or outside of is there a past earlier than my time? Is whether time is a property of the universe or if it's a property of how we interpret and process the universe. So I'm imagining a universe in which there is no time, but everything is happening in simultaneity.
Are you going to ask us if the tree makes noise?
Stretches it out into this linear kind of, this happened before that and that happened and took time. But that to me may be something that's part of my processing of all of this rather than something that's inherent in the structure of the universe.
I don't have an answer to that in this context. What I would say is it was probably equivalent to if we stretch out the time coordinate as we do and everything happened at the exact spatial coordinates. So if everything that ever occurred, every event, everything, every interaction, every happening all occurred in the exact same spot over time, that is probably equivalent in an important way to what you're describing and may help.
Everything, everywhere, all at once.
All right.
Isn't time dependent on an observer?
Is it?
Yes.
Oh, okay.
So here's where we're going with this. All, again, in the interest of time. Sorry. So for the purposes of our conversation here, this is all great, and this would normally be a whole class by itself because it's fun, but I have a limited time with you. So an event for our purposes needs to happen in some place at some time. And that's really all. Can we all accept that? Are we all cool with that? Any objection to that idea? That an event, if it happened when, nowhere. If something will happen, nowhere, or did happen, nowhere. I don't think that happened. I don't think that really is an event. I don't think that's a thing that occurred as far as what we want to talk about tonight. And thus, if we flip it and say it happened here, never, we get into trouble. So an event, a thing, a happening, an occurrence, needs to happen in spatial coordinates and a time coordinate. And the reason I'm telling you all about this is because I don't know how long it's been since the Silvera talk had graphs that were drawn, but we're going to do a graph. So, I hope I don't give some of you flashbacks to bad experiences in school. Can everybody see the XY diagram sufficiently well?
You've got thumbs
I
up?
see some thumbs up. Okay. So, why am I doing all this navel gazing on this stuff? Probably driving people nuts. Have we lost any yet? Oh, no, we've gained some. That's surprising. All right, so. we have an XY graph. Now, in this case, our x-axis is going to be space, is going to be moving in a space. Okay, I know this looks really silly to you. Thankfully, they can't see my feet. Okay, now, because I suck at drawing, and this is a two-dimensional surface, this is a 2D XY graph, which means we have one spatial dimension. Just to simplify this, it's hard enough as it is. One spatial dimension. So in this space, we can go left, and we can go right, and nothing else exists. There's no up-down, there's no forward-back. Which should beg the question then, well, what's the up-down axis mean then? The up-down axis is time. That's totally a T. Okay? So, up and down is time, left and right is one dimension of space. Rick, you're squinting.
I'm trying to understand why there would be a negative time.
Well, hold that thought. Because would we all agree if this was the time axis, that it's probably convenient that we call this the present now? Do we all agree that's probably useful?
Sure.
Therefore, a negative time coordinate from our relative to our current position in time would be the past, right? And thus up here would be the future. Okay. Now, if you are a thing that, as far as this graph is concerned, if you are holding this graph onto you, so the graph is moving with you, and you're not moving from your perspective, then your experience is you just kind of hang out at the same spatial dimension and move forward in time at a rate you will fail to be surprised as being 1 second per second. Sorry, I love that joke. I'm going to inflict it on you because I love it so much. Right, but if you don't move, you're just going up the time axis at a rate of 1 second per second. There's nothing you can do about it. Time seems to flow in one direction consistently, regardless of what we have to say about it. If I step to the right, okay, my right, Zoom people, then what I have done is I have stepped to the right 1 tick, and then I will stay there as I go through time. So I can plot, if I zigzag in space over time, that would look like a zigzag going here. Does that make sense? And if I wanted to draw the zigzag that I just did, that could be represented down here. Give me a thumbs up in person and on Zoom if this makes sense, everybody. Okay? If this is really basic, I apologize. I just want to make sure we're all on the same page, because this might be new to some people. So,
are we getting to general relativity tonight?
special relativity. We're getting there. We're getting there. All right. So, the reason I called this a space-time diagram is because, and here's where I know there's special relativity in the title. Thank you, Kevin. I'm going to skip something to get there a little faster. So, the speed of light. We're going to leave aside the whole invariance to all observers, Lorentz transformations, too much for tonight. What we are going to say is, we're going to have our vertical axis be time, where 1 tick is equal to 1 second. And on the x-axis here, 1 tick is going to be equal to 1 light second. Now, if this is a new term to you, a light second is not a unit of time, it is a unit of distance. So when we say light year, we're not talking about a year as in an orbit around the sun, we're talking about the amount of distance that light travels in the time of a year, okay, which is a velocity. It's an incredibly high velocity, 300 million meters per second, roughly. And the reason I am doing this horizontal in 1 light second is because this does something very convenient for us. Because if I want to draw the speed of light on this graph, if I say I'm emitting a photon, a lot of photons, but I'm talking about just one right now, to the left, or anything on these space-time diagrams, and that we end up with a 45-degree angle, always, no matter what. You will notice that this region is going to become somewhat lonely and empty, because for anything to occur here that I could affect, I would have to have an effect that traveled faster than light, which is illegal. Can't do it, okay? Let's say something is traveling at 50% the speed of light away from me. That would look like that. It would look like half of a 45-degree angle. If something was 1 light second away from me, but not moving relative to me, that would look like this. It would be a parallel line following my axis, my direction of travel through time, so to speak. Give me a thumbs up if I've still got you. Okay.
We got thumbs up from the...
Does anybody have any questions or confusions? Do we need any clarification before going forward? Because if this doesn't make sense, the next 10 minutes are going to be very confusing.
So what you're saying is you have this cone of possibilities that travels with you.
Doesn't travel with me.
That
Doesn't
you
travel
travel within.
Well, oh, no, I misspoke. Yes, the cone travels with me in a sense. In a sense. In that as I move forward in time, there is every instant of time a new light cone going forward from there.
Like how headlights travel with the car.
Yes, that was, yes. Sorry, I misspoke, my apologies. All right, so in this example, I think we've figured out this is the future, and the infinitesimally tiny, very difficult to define point here in the center is the present, and thus, down here is the past, right? Now let me ask a question. Has Betelgeuse exploded?
We don't know.
Yes.
From our perspective, has Betelgeuse exploded?
We don't know.
Maybe she knows something we don't.
It is slightly clear outside. If we went outside and looked up, would we see Betelgeuse?
That doesn't answer the question.
Is it up?
If it's up.
Yeah,
What's up?
it's
Orion.
It's up, it's up.
Has anything in Orion exploded?
We just saw it.
We just saw it. Okay, I was wait, Orion, Betelgeuse is up. Now Rick's asking a good question. I don't want to pick on you. Have I exploded?
Well, there's a much shorter interval. So I don't think you have, but I'm still seeing your past.
Rick, do I have your permission to pick on you slightly for educational purposes? Have I hit you with a marker?
No. Still haven't.
Okay. All right. Since I asked Rick the question before I threw a marker at him, his answer at that point was correct in that no, I have not struck you with a marker, just as I have not exploded, nor from our perspective has Betelgeuse exploded. Now in astronomy, we like to do this. We like to say, you're looking at light, that star might not even be there right now. And the mistake we might make is the right now. And we're honest, we say, it took this long for the light to get here. And I'd say, that's okay, we can do that, right? And I even do this with my students. I say, student, if you could teleport, you can't, but if you could teleport to that galaxy, and you had a perfectly amazing, impossible telescope and looked at Earth, you'd be looking at dinosaurs.
We have a comment from Tamunala in the chat
Yes.
that we would see the light from Betelgeuse that left however many thousands of years ago.
That is absolutely correct. And that's the point. When that light left Betelgeuse and began its travel to us, Betelgeuse had not yet exploded. So, let's ask the question. Let's draw our past light cone. We all agree Betelgeuse is some distance away, at least a few light seconds?
Yeah.
So what we have here is the spider of possibilities.
That's Betelgeuse.
Mine's cool.
Exploding. Has Betelgeuse exploding happened in our past? Notice what I'm saying. In our past.
Well, draw it within the cone.
No.
It's arbitrary.
I don't want to draw it in the, I don't want to draw it in the cone yet. Zoom people, do we agree that Betelgeuse has not exploded in our past in this example? Has the event, I'm going to write it again for emphasis with an N that totally looks like an N. Has the event of Betelgeuse exploding had a when from our perspective? Can we assign a time coordinate to Betelgeuse's explosion?
No.
Therefore, has that event occurred for us?
Schrodinger's Betelgeuse.
No, not quantum, not quantum.
I guess
This is classical. This is relativity. What?
if you're defining it, no.
No.
I like that, as he's defining it. I disagree with you. I get the point you're making, and
Tell me why you disagree with me.
because it feels wrong. Because I know
Good, that's what I'm trying to mess with right now.
well, it has happened in the past. It just hasn't happened in our past.
And tell me what the difference is again?
Perspective.
Okay.
Objectively, it has happened.
So who's-
To us, it hasn't happened.
Well, hold on. So relativity, one of the base postulates of relativity is that there is no absolute reference frame. There is no one ring reference frame, the reference frame to rule all reference frames. Everybody is playing with the same limitations. We are all the centers of our own little universes. In physics, you get to be narcissists, okay?
Or postmodernists.
There is no totally absolute authoritative reference frame.
There's also no reason to believe that time is constant. It could be elastic as all hell.
It is, because we're going to get into how time stretches out using this graph very briefly. And time is, what I'm saying is time is just as relative as distance. If I move to my left, Rick, what direction am I going?
To my right.
To your right. Now we do this in our language, we say my left, your right, and we get that because we've run into this problem. But when the mosquito hits the windshield of your car, is it accurate to say that you have crashed into the mosquito or the mosquito has crashed into you, or do we understand that it doesn't really matter and it's how we define it, right? Yes?
This is just a point that has always confused me a little, where we're talking about light, but not everything moves at the speed of light.
Yes.
There are lots of things that are slower than the speed of light, like you threw in
Like
the marker.
Toward, but not at.
So how does that fit into this picture of reality in which things didn't happen or did happen?
Could I beg your patience for about 4.5 minutes?
Yes.
Okay. Because the reason I'm talking about light right now is I want to define maximums. Is I want to give the maximum possible case. And then we'll get to that in just a moment, I promise. All right, so let me finish this up first though. So for Betelgeuse's explosion to affect us, the light speed part of Betelgeuse's explosion will travel out from Betelgeuse in its own future light cone. If I shine a laser pointer at something, that laser pointer can only travel at the speed of light. Therefore, I can only causally affect things that are within my future light cone. If I want to poke something over here, fundamentally impossible as far as our current understanding of physics is. Don't say the words entanglement or wormholes or Einstein bows. Just don't do it. Okay? Just don't do it.
Spooky action at a distance.
Don't say those words. So we're kind of early 20th century conceptions right now, okay? I'm a high school teacher, come on. So I cannot affect this. Because it doesn't lie within my future light cone. The signals from me will never get to that point in space and time.
But that's not the same as saying that I can't take a green laser at night and say, there, that's where I want you to look to see Betelgeuse. And I don't mean Betelgeuse, I mean what came from Betelgeuse a long, long time ago. But still, I'm hitting it.
No, you're not.
Well, not Betelgeuse.
No, but that's very interesting. What you're actually bouncing those photons off of is the air in our atmosphere that is then bouncing the light back to our human eyes on much shorter time scales. You are actually pointing at this. It just happens to be in the way of Betelgeuse.
This is why it took it 3 times.
I'm going to have to sit with this for a little while.
Now let me give you another example on that. Let's say you point a laser pointer towards Mars.
Yeah.
And no, let's do Jupiter and Saturn. And then you flick your wrist and flick it to Saturn. Have you just violated the speed of light because the laser pointer traveled from Jupiter to Saturn like that?
No.
No. And the answer to that should answer your earlier question.
Because it's like spraying a garden hose.
It is.
Spraying the photons.
Yes. It's like you've thrown water droplets at one and water droplets at the other. The droplets are different. The droplet did not travel between them, and it's because the droplets you're looking at are reflections from our atmosphere.
Trying to make the argument that I'd actually hit
Yes.
Betelgeuse with that. It was
But the reason I'm correcting
a
you is
long
important.
time going before it does.
Yes. But the reason I'm correcting you is because it is an important difference in what is reflected back to us. It's closer. It's much more
You
local.
probably need to lead it some.
That too. So, all right. So, what has to happen for Betelgeuse's explosion to become known to us, to be an event that we can assign a where and a when to? what has to occur for Betelgeuse's explosion to enter our past light cone such that we can say, oh, it blew up, and assign a when. Betelgeuse is there tonight, tomorrow night it might not be. We could say, oh, it blew up January such and such, What needs to happen?
The cones have to overlap.
Yes, the cones need to overlap. We need to move forward in time, as we will, until there is enough time for the photons from Betelgeuse to intersect us, which will happen roughly then.
Yeah.
And from our perspective, Betelgeuse blew up then.
Tim also said in the chat, it has to enter our present/future time.
Exactly. Okay? So, and if Rick were to blow up Betelgeuse with this damn laser pointer, we would have to wait some significant amount of time for the laser pointer to get to Betelgeuse to spark the causal chain of dominoes. You knock the domino over.
Immediately use determinism as my defense to do that.
So in other words, for us to have any effect on something, it must lie within our future light cone. For anything to have affected us, for us to even say it happened, it has to be within our past light cone. Does that make sense, everybody? Is anybody lost on that concept right now?
I think I'm lost on that. I will agree with you on the future more readily than I will that the past has to be within my... I don't get that yet.
Okay, let me give an example of something we talk about in astronomy a lot that requires understanding this. So that, by the way, this is the special relativity part of the talk, because this is a kind of simple, like, fundamental part of special relativity. It takes time for information to travel. Now that's different, because like early 1800s, light was still believed to be instantaneous, which means everything in the universe can become known to you now, like instantaneously, because everything traveled like
If Betelgeuse just blew up,
that's it, you know right now.
Yeah.
The finite speed of light was a huge deal, big deal. It was not until the Michelson-Morley experiment that we really got that one. Yes?
I have what sounds like a joke question, but it's sincere. For the purposes of what we're discussing here and now, are the past and the future meaningfully different?
Yeah, one's that way and the other one's that way.
Cool.
Yes, it is as different as I am in this spatial location, and I can talk about this spatial location and this spatial location. It's just temporally, which is weirder. We have trouble with that. We do.
Right, because you can't shuffle back and forth.
In space, we can move in both directions.
Yeah, but I mean the other axis.
And in time, we, for reasons that are highly complex and I don't think we quite figured out yet, can't.
Therefore, they are different.
They are different.
And it's maybe easier to make a dominoes kind of an argument about the past. That is the only past there is, and it's beyond changing.
Oh, interesting. Beyond changing.
Whereas the future may or may not be.
Okay. I like it. I like it. So, let's run with that for a moment. Zoom people, you have any questions, comments? Have I lost any of you? I know the in-person audience is talking a lot. I want you to please unmute and interrupt us. Make your voices heard if you choose to do so of your own free will or because of the Big Bang. Either way.
All right. How the past of Betelgeuse exploding, when we would see it with that light cone graph. Can you go over that again?
Sure. So if Betelgeuse's explosion happened, let's imagine we could teleport. Let's imagine we could violate the speed of light and we teleported to Betelgeuse right now and it wasn't there anymore. It had already gone supernova.
Okay.
The photons, the information of that event has not yet traveled through space-time to arrive here at Earth, which means from our perspective, Betelgeuse is just still Betelgeuse.
Yeah.
And it will take time for the event of its supernova to reach us. Now, in astronomy, when we talk about things we like to do, oh, you're looking, we have to be careful. Because what I'm suggesting for the purposes of here is that we talk about is only what we can really talk about, which is anything that has happened within our past light cone. Because if an event occurred, but no information from it has reached you, that is indistinguishable from an event that has not occurred. Let me say it another way. If this marker exists, but no information from the marker ever reaches you, you can't tell the difference between this marker existing or not existing.
For now.
For now. But then you're like, well, it's going to exist. We'll prove it. Well, wait. You can't. What color is the marker, right? You have to get information from the thing in order to know anything about it. In order to say this occurred, this exists. This is a thing in the universe.
It seems to me that at some point common sense jumps in, just as it does with Zeno's paradox. If you punched Zeno, you would have said, I did get there, didn't I?
Eric, can you...
Do you want to punch me? Is that what you're saying?
Not yet.
Sorry, what was that? What was that, Gregory?
Can you label which parts of those light cones, those 45-degree angles are past, present, future? So that, okay, so that's the past. That's the future.
Yeah, for some reason, it's always drawn as time going forward being up, but we could just as easily flip it. It's arbitrary. All right, so...
Now, on the right-hand side, that's still the future, and on the right, so that's still the future there, and that's still the past up.
Yeah, this is future, but that way, that direction. to the left or to the right, depending on whether the camera flips it. All right, so.
So the question I just heard, are you going to draw the light cone at a future time? Or
Thanks for heads up.
Well, we can. So in.
I couldn't hear.
Oh, he asked if I'm going to draw the future light cone at a future time for us. That would simply look like, just to avoid clutter, this just goes this way. Every second, it goes up one tick on this graph.
Dragging the past behind.
Dragging the past by it. Yes, you're both correct, as well as dragging our past light cone. So that's very interesting. Because let's pretend that this is finite down here.
And that's when the past does intersect that.
Yes, which is the point at which Betelgeuse's explosion becomes known to us. Now, let's just for the sake of argument, the universe began at a time. Don't throw things at me. Let's just run with that. That means at some point, this past light cone would become so sufficiently large, right? Because every second, an increasingly larger amount of the universe lies within our past light cone. Does everybody understand that?
Say that again, please.
Every second, our past light cone gets wider at the bottom. More stuff is now in it. More stuff has had time to get to us. And here's the astronomy example that I know any of you have done any astronomy talks or anything like this, you've heard the cosmic microwave background radiation, right? And it's a weird question. It's like, well, wait, if we point the not pigeon poop affected satellite dish, radio telescope, excuse me, in every possible direction, how are we getting the same signal from every possible point in the universe? And this will help you understand that. Because if the cosmic microwave background radiation, when it was not microwave, when it was hot and much more energetic, much closer to the human visual spectrum, even past the human visual spectrum, bright, right? If every XYZ coordinate in the universe was a flashbulb going off, then as we move into our future, more and more and more and more of those original flashbulbs from 13 point something billion years ago are entering our past light cone, and that particular photon just happened to finally have time to hit us. Which is why we still see the cosmic microwave background radiation in every direction. Because you've been seeing the cosmic microwave background flashbulbs that happened in your light cone. But you haven't seen this one yet, or this one yet, or this one yet, or this one yet, but you will. Because it needs time, just like Betelgeuse's explosion, to catch up to you. And there's also Doppler effect and redshifting and all that good stuff. But I hope that helps a little bit in like why that happens in every direction, because you're catching photons that had just happened to have been traveling from that direction from your perspective, and it just didn't get into your past light cone until that point in time. Okay? Uh-oh. Are we good? All right.
Yeah, thumbs up.
Thumbs up. Okay. Let me check my notes here. So, I'm going to bring us...
Question, though. So, like, isn't it also because with the expansion of the universe, the where on our graph, as our light cone expands, is also getting...
Yeah. All right, so it depends on now this is dark energy and the expansion of the universe and possibly new physics, because I hope most of you have heard that like our really reliable methods for measuring the expansion rate of the universe, we have two teams, well, more than two teams, the main two teams working on this. We were like, oh, we have different numbers, but they're sort of close. We're going to refine our measurements, and it should be in the error bars right in between. And then they did that, and they went away from each other. And now we're like, oh, crap. New physics might be on the horizon to explain this, which is exciting, and it has to do with the expansion rate of the universe. But that's a whole other talk. What I want to talk about right now is the expansion rate of the universe is actually more like the distance between these tick marks getting bigger.
Stretching.
Stretching, yeah. It might not be correct to think about it as new tick marks being added as the space between existing tick marks getting larger. But that is a whole other talk that don't get me up. So, all right, where I do want to go is I want to go back to you, because I said 4.5 minutes and apparently I was a horrible liar. So let's imagine, this is getting a little complicated. Let me clean this up somewhat. So let's imagine we have a fellow traveler. And our fellow traveler is going to be, let's stick with red for our fellow traveler. And I'm going to get rid of that. And just to be visually simpler, our fellow traveler is going to be here, which means, by the way, we don't know that the fellow traveler exists yet. Okay. But the fellow traveler in the space coordinate is not moving relative to us, which is another way of saying the distance between you and your fellow traveler is not changing. Now, one fellow traveler is going to be staying with you, and another fellow traveler is going to be moving away from you, and I'm going to start it at the same origin, at 50% the speed of light. Is everybody following here? So let's call this C, and let's call this B, and U, and the center of the universe, your universe, is A. Okay? Because I am not creative. So, and let's all say that we're going to agree that at t equals 1, everybody's going to blink a flashlight. Y'all follow what we're going for here? I wish I had more color markers. I'm going to try this in black. If it gets too convoluted, let me know. So at t equals 1, which is right here, you blink a flashlight. That flashlight travels at the speed of light, 45-degree angles outward, right? It will take time to get to your fellow travelers. And conversely, your fellow travelers who have blinked a light at t equals 1 will take time to get to you. And I'm sorry, this is really small. I normally draw this bigger. Maybe we should, how can I do this? I'm going to get rid of our past. I'm going to draw this a little bit bigger.
Only if it's that easy.
Sort of like what bankruptcy.
Don't panic. Keep calm, carry on.
So the kids usually don't laugh at this joke as much as the adults do, but I like to sometimes pose the question of, so according to special relativity, if you run sufficiently fast, can you escape your past? All right, so let's actually simplify this to one fellow traveler who is moving at half the speed of light, and speed of light now is going to be red. And so we have our light cone, and we have our fellow traveler's light cone in both directions. Okay? So, let's change the example a little bit. So you are going to blink, what color are we? We're green. You are going to blink your light, beep, 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 once per second. So I'm going to add some tick marks here. Now, as you move forward in time and you are green, so the graph is referenced to you who is green. That's the wrong marker. That's why that's not working. Yes, screw it. All right, so you are in green. You're going to emit a photon here, and you're going to emit a photon here, and you're going to emit a photon here. Everybody got it? You measure 1 second of time in between each of your blinks, but because your fellow traveler is moving at a less than luminal speed, do you notice that there's some more vertical distance there? I know this is not the greatest of graphs, but do you all see that that's a little taller? Okay? So it takes some time to get there. And the way I've drawn it, see that arrives a little later, and that arrives later, and that arrives later? Part of this is my bad drawing, but if I drew this perfectly on a graph with the math correct, this would still occur. Here's an example of it. Oh, I threw those away. Oh, wait, there's one. Let's do this. Could I ask you, is that okay? And Kevin? All right. Zoom people, I can see how I do with this. On the count of 3, you're both going to throw the markers at it.
No.
Unless you drop them. Now, I am going to position myself roughly equidistant between them, and I'm not going to move. So on the count of 3, throw your markers at me. The markers are the photons, the light information being emitted by the blinks. So ready? 1, 2, 3, throw. Okay, and I can't catch 2 things at the same time, I just learned. But they both struck me at the same time. Zoom people, did you see that?
No.
Let's do it again.
Okay, we are going to do it again.
You actually did it.
Because I'm going to, sorry, I also can't throw 2 things at the same time. All right,
Move faster.
you're going to want to aim a little bit more this side.
Oh.
Okay?
No more that way?
Yeah, hit the board.
That's the board.
Okay, on 3, you're both going to throw the markers at me. 1, 2, 3. What occurred?
You were moving
Sure.
into
You
the
were-
path of
yeah,
one and away
stationary.
from the path of the other, I suppose.
As far as I'm concerned, because I'm the center of the universe, Kevin threw his marker significantly sooner than you threw your marker,
It does.
despite my explicit instructions to throw them simultaneously.
And
See what's happened
the
here?
fact that they were both traveling at the speed of light.
Yes. Now, this is assuming the marker is traveling at the speed of light. Your relative motion means that if you're heading towards the cause of something, you will experience that sooner. And if in this case you're traveling away from the cause of something, you will experience it as happening later.
Just Doppler, or is it more than that?
It's similar. It's in the ballpark. Let me say it another way. I will see on my clock is tick, 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 tick. If I'm looking at the light from your clock, if you're moving away from me or I'm moving away from you, there's no difference fundamentally. I will see your clock ticking slower because, let's say it flashes once per second. The time that I measure between the flashes is longer than 1 second. This is the time dilation that ends up in relativity. And this is another useful thing with the space-time diagram that teaches us why this happens. It also tells us that things that are simultaneous for one observer are not simultaneous for another observer. If I was moving the other direction, you threw your marker first and you threw your marker second.
So you're flying into the headwind, basically.
Sort of, yes. Now, I know I'm glossing over, people on Zoom, don't get mad at me, I know I'm glossing over Lorentz transformations and the invariant speed of light for all observers. We're not going to get there today. Okay. But this still happens. I'm exaggerating it, but this is how time dilation occurs. Okay, and this is where you have, I'm going to just reference it, but this is where you have the train car thing, and you have somebody standing on the platform, and you have somebody in the train car, and lightning strikes both ends of the car at the same time, and if the train car is moving relative to the stationary observer on the platform, stationary, they will disagree on whether the lightning bolts hit simultaneously or one hit and then the other hit. And a bird flying in the other direction really, really, really fast would say, no, 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 you got the order backwards. And none of them are wrong. That is an effect of all this light cone stuff, because it takes time for the information to get to you. So, I have another question I want to ask for y'all. So we're going to switch back to philosophy for just a moment, because I want to be careful that I don't take up your whole evening. So we're going to talk about the past, the thing down here again. And I will come back to this if we need to, but I want to ask you a philosophical question. Can you change the past? Or can you change your past?
No.
Does anybody on Zoom think that you can change the past?
Not your past, but being that our present may be others, or our future may be others' past, then yes, we can.
You have jumped ahead. You are going where I was going.
Sorry.
That's okay. That's perfect. That's perfect. So this is where I like to blend the physics and the philosophy. Now we're glossing over some stuff, but you all agree, I think everybody, I've never met somebody who said, no, I can change my past. I mean, that would be interesting. We consider that to be set. It already happened, can't change it, done. But, sorry, what Temu just brought up on, did I pronounce that correctly? I'm sorry. Got it right? Cool. What you just brought up is, if, for example, your light cone is not perfectly aligned with somebody else's light cone because they're over there and moving, and I know we're not doing acceleration, that's too complicated. But if they're moving, right, or we're just slightly misaligned in the space axis, and one observer's past light cone might be our future light cone. So for example, let's talk about something over here that is outside of our current future light cone, but will at some point be part of our past light cone. But you notice now you're saying, well, wait, I'm talking about the future because they're up on the time axis. No, from their perspective, I'm talking about the past because you're down there. Yes?
This ties into a question I had about the explosion of Betelgeuse.
Yes.
So you can say that it hasn't happened for us, even if it has happened for it. But also, if it hadn't happened at all, then we would never get the information.
Correct, which is why we can't say it happened for it because that information never arrived to us or has not yet arrived to us. So we cannot assign a when to that event, and therefore my argument is that event has not evented, it has not occurred.
So
Therefore, we can't truly talk about what has happened for Betelgeuse because that information hasn't gotten to us yet.
So in that sense, the event is not a single stationary thing, but an expanding shell moving away from the star at the speed of light.
You can describe it that way, and I think that would be reasonable.
Okay.
I've heard it described that you are not you right here, right now in this particular XYZT coordinate, but you are instead a line, a segment of, a series of coordinates of all events in all places along your lifetime. Like you, what is you is just a series of events at a significantly large number of coordinates of all the things that you were present for. So right now you're in this room at this time, later tonight you'll be somewhere else, tomorrow you'll be somewhere else. You is all of those series of coordinates.
Marley's chains that he drags with him.
But here's where it gets tricky, and here's the philosophical part we're going to swing back to. Because if events that are in your past are in other observers' future, and you consider your past to be unchanging, unchangeable, already set, already happened, that's just the way it is, well, how is that person whose future it lies in going to reasonably say that they can change their future if from another observer that event has already occurred? And that is where I want to kind of bring us to. Yes?
Your past is not the totality of their future. It is an element. It is not the whole.
Could we identify enough observers to cover every possible square inch, so to speak, of your future light cone?
Of your future?
Yeah, because what I'm arguing is that your future light cone might be inhabited by the past light cones of other observers, other events, other interactions. And if their pasts are as fixed as you believe your past to be, how do you say that your future, oh, I forgot to ask that. Would you, who until 3 minutes ago thought that your future was changeable, not set, not fixed, not defined yet, not determined?
Got some people.
Yeah, I see some notes, right? So think about it. If, however, your future light cone is part of another observer's past light cone, who just happens to be at different coordinates than you are, how can you say your future is pliable, is flexible, if their past is not? You have a paradox, you have a contradiction.
What is this other person and where and when?
Well, from Betelgeuse's perspective, it's us. From our perspective, it's some future event outside of our future light cone now, but might become later. Yes?
So I was a pretty staunch determinist, and now I'm wondering, is it determined when there are other observers present, but then not determined if one is alone without other observers present?
I would say none of this applies in the one thing universe.
I feel like we're
Because
being...
you have nothing to be relative to.
So when I'm alone in a room, am I...
Well, if you are the one particle in the local space-time who has never been causally affected by any other interaction ever and will never affect any other interaction ever, then, yeah.
So particles are observers.
I would, okay, so we want to be careful when we say observer. A lot of people think we mean conscious things. To two rocks bumping into each other can be an observer in a sense. I would say it's why I prefer the language of an interaction, an event, right? So if an electron drops an orbital and emits a photon, that's an event. That is the thing that has occurred, but you don't know it occurred until the photon interacts with something else to convey the causal chain, to convey the interaction, to convey the information. Right? This is a really complicated version of saying if a tree falls in the forest and nobody hears it.
I feel like we're being offered a somewhat unconventional, but not necessarily paradoxical choice, which is either we have to accept that everybody's past and everything is subjective, or we have to accept determinism.
I am setting up a false dichotomy in a way, yes. But I'm doing it for the purpose of provoking debate, not to try to convince you that this is what it is, because I have left out some things that disprove this for the purposes of sparking some debate.
I spent years chasing my own tail on this. The answer that makes me happy is just that the decisions that govern me come from within me. Exactly how that happens doesn't really matter.
And
I'm dodging the question, but that's the best dodge I have.
And moving from physics perilously close to theology or some such, that is the position one should take, because determinism allows you to choose to do any damn thing you want and say, oh, had no choice.
If we abandon free will as a culture, as a species, as a society, and we embrace determinism as far as our moral liability is concerned, that has some pretty significantly massive, terrible implications.
Does it though? Because the jury can just say they had no choice but to convict you.
So a debater that I used to like but no longer listen to had a really good thing that I feel like summed this up, which is that you could decide to get up and leave this room, or I could club you over the head and I could drag you out of this room, and the difference between those two things is everything humans actually care about when we're talking about free will.
Yeah.
Yeah, that seems about right.
Now my argument would be, if I can be personal for a moment, is that in either case I would argue that past particle interactions had a role to play in whether you decided to do it on your own or whether I decided to club you over the head instead.
Well, yeah.
But what humans care about is the difference.
If some mental illnesses are amenable to treatment with chemicals, those chemicals are dominoes, if you will.
Mm-hmm.
I mean, they're...
But so is the mental illness, and so is the reaction to the treatment for the mental illness, whether it's successful or whether it's not successful, whether, you know.
See, this is why I'm okay just saying the decisions come out of my brain.
Yeah, well that's...
Like, I'm not wrong. That's not the whole answer, but I'm okay.
So I'm going to bring in one other thing that I skipped earlier, which is, has anybody ever heard of Laplace's demon?
What?
Laplace's demon. So Laplace, I want to say this is early 1800s, 1815, 1812, somewhere around that neighborhood. So pre-Einstein, definitely pre-quantum. We thought light was instantaneous, right? Early conception of it, post-Newton though. And the idea was, if you were able to know at your present moment perfectly, so we're already in trouble. If you had perfect knowledge of the position and momentum, basically all of the information about every particle in the universe at that moment in time, at that time coordinate, you could basically just run the physics backwards and figure out everything that occurred before that would lead to the current configuration. And therefore, you could also reverse the math and run it fast forward and say, I could then predict the future position at any given time of everything in the universe, and thus you would have perfect knowledge.
The clockwork
And
universe.
then you change the past, right? Because if you're moving at a different speed, you decide, right? Are you then changing the past?
Well, this is pre-special relativity, so the light cone thing was not in their world because they thought light was instantaneous. So for them, the x-axis is the light cone, so it wouldn't have mattered. If I understand your question correctly.
If you accept those conditions, then yes, you're just turning the crank one way or the other. Doesn't
Yes.
matter.
Now, in that conception, the universe would be absolutely deterministic. If that bothers you, you'll be happy to know that Laplace that idea has been broken 15 different ways. But it is an interesting thought.
Well,
It is an interesting thought.
it stumbles in the real world on the word perfect.
Yes.
We don't have perfect knowledge of everything.
We don't have perfect anything.
No. So we have functional free will, if not actual.
And special relativity actually breaks Laplace's demon, because Laplace's demon could only know information from its past light cone, which does not encompass all that much of the universe, really.
Are you going to talk about the arrow of time?
I kind of referenced it in a sideways way.
We got a comment in the chat from Christine Diorio.
Yep.
It is also interesting when people think their decisions come from within them, because the very boundary between us and the rest of the universe, governed by physics, etc., is just based on our limits of our body's sensory perception. So in my opinion, we decide, but in a way entangled with the rest of the universe.
That's entirely fair to me.
Yeah.
I agree.
I mean, so my personal argument would be, yes, it comes from your brain, which is made of matter and energy arranged in a certain pattern, which is the result of previous interactions of matter and energy in certain patterns following a causal chain, governed by the laws of the universe, whatever they may be, that resulted in the current configuration.
Could you imagine how much worse it would be if that wasn't true? You never got any input, how boring that would be? You'd lose your mind.
All right, now I'm going to say, I shushed somebody earlier, but we also got to say, and then quantum mechanics.
The good stuff.
Where it's not, pool balls, billiard balls bumping into each other in perfectly predictable ways. It might be fundamentally probabilistic, at which point your predictive ability, even if you had perfect knowledge now, which also might be fundamentally impossible due to Heisenberg's uncertainty principle, among other things, essentially you end up being blind till about here, or blind after here. It ends up not being all that great. And then there's an interesting question of whether that actually fundamentally hurts determinism, or do we have to redefine determinism so it is determined probably, probabilistically. Okay? And does that save free will?
For the
Does that
last,
save free will?
this is almost too convenient. For the last 20 minutes or so,
Sure.
I have been watching a small insect just travel around on the ground here, and the path it is taking makes no sense to me. Oh, perfect, yes.
This is Kevin's fellow traveler.
Yes, this is my fellow traveler. The path it is taking makes no sense to me. It has the answers it needs.
Okay.
That's enough.
Okay. Gregory.
Eric, can you explain again how the past and future is someone's past and someone's future? I don't quite understand that, how someone's past can be someone else's future.
Yeah, it's...
That kind of confusing.
Yeah, I'm glossing over it a little bit due to time and other restrictions here. So, we're going to return to the center of our own little universe. So you're going to be blue, right? And here's your future light cone, and here's your past light cone, right? So this is everything that could have affected you up until this present moment. This is everything you will ever affect ever, for ever, period. So we can.
What's the present?
And the present is, that's too big, but you get the idea. So the past everything below the line, future everything above the line. The infinitesimally small line itself is the present. So what I'm suggesting is that, let's say Betelgeuse exploded here, and let's say that there was a planet around Betelgeuse, that Betelgeuse's explosion definitely affected it in shorter time scales, right? Betelgeuse's explosion's light cone travels out and envelops the planet. Let's actually put the planet a little bit more in the path here, right? Planet had a past, blew up, got incinerated, vaporized. That has occurred from the planet's perspective. Has it occurred from our perspective?
No.
So it occurred in our future. But can we do anything about it?
Oh, I see. It's not occurring in our present, but it will occur in our future. But
Yes.
it happened in the past. Oh, okay.
To a different...
My information hasn't had time to reach us yet. Is that what you're saying?
Now that's also true if I draw that up here. In our future, but the information won't get to us until further in our future. See where I'm going with this? So I'm glossing over a little bit due to time constraints and other things, but it's a very oversimplified way of it, in that you have to be willing to imagine observers or plot observers that don't share your T. And remember, the reason I did that little sidetrack of the non-simultaneity of events is because there is no absolute time. Time is just as relative as location, as space. Which means your now is only your now. It is nothing else's now except maybe by coincidence. So when you say now, think about it, there's some lag. The air molecules have to travel to the microphone, be converted to signals, that takes time, transmitted over to the internet, gets to your ears, and then you respond to me. Like, there's a lag time there, but we kind of call it now because it's close enough. But it's not really. There's a significant lag time there. So even to say, now, what you perceive as me snapping my fingers is at a different time. If we could teleport to when I actually snapped my fingers and that doesn't bother us, we're just doing this on a much larger scale. Does that help any? Okay.
Yeah, it makes more sense. I want to mention something, the Galilean relativity, where, if you're traveling in a straight line at constant speed, you can't tell the difference of that as far as being still. The laws of physics are the same.
Yes.
I actually experienced that, which really fascinated me. I was on a cruise ship, and I woke up, and we had I couldn't look out the portholes because they were closed. So I took my shoes off, and I could feel the engine, the vibration. But I couldn't tell if I was moving, so I walked across the room from one to the other. I jogged it. I jumped up and down. I took a piece of paper and threw it out, and it fell right. I didn't go forward or anything. And then I made the decision. I said, we must be done. I opened it up, and we were moving. And I couldn't tell.
Yep.
It just blew my mind that, try that next time you're on a cruise ship. Just don't have any windows, any reference, and, wake up and not know whether you're docked or moving, because the ship moves at a constant speed, unless it's rocking back and forth. But the water was very still, so I couldn't tell. No matter what I did, I couldn't tell. That I thought I was, we were docked. I was still, and the water was moving like this.
It gets worse for you because if the cruise ship were in space moving at 0.9% the speed of light, you'd also wouldn't be able to tell.
Yeah.
As long as there's a constant speed. So
How
Einstein...
fast it was moving, as long as it was constant speed, you couldn't tell that you were stationary or moving at a constant speed. It didn't matter what the speed is in a straight line. I mean, fascinating to actually experience it.
And another twist on that is even if we add acceleration into it, Newton would say gravity is a force, right? Einstein would say gravity is not a force. Like, let's think about that. We say the 4 fundamental forces of the universe: strong nuclear force, weak nuclear force, electromagnetism, and gravity. And we got Einstein being like, no, 3. You don't put gravity on there. Right? We don't have a graviton for a standard model for a whole lot of other reasons, but gravity may not be a force, but it might be a fake force, in that if I put you on a rocket and accelerate you at a rate of 9.8 meters per second squared in space with blacked out windows and portholes closed, you will not be able to tell that you're not just in your bedroom on Earth. Because you will feel gravity. And remember, this is from the person who I believe this is an accurate quote, would say the greatest thought of his life was thinking of a man falling off of a roof. I love telling my kids that. They love it. Because he realized that the man is not accelerating downward. The man is not falling. He's floating. And the earth is accelerating up into them. And
The
this
way
being
I
an
heard it
explanation of
written
general
down.
relativity, which we can't get into too much tonight, but it segues into your idea that it's fundamentally indistinguishable.
I think I would feel it.
Sorry, Rick.
If I tried jogging or something, I would feel a force because it's accelerating.
Well, you do. Stop. You're sitting right now, right?
Yeah.
Stop pushing on the chair. No, stop pushing on the chair. Don't push on the floor either. Stop it.
That's the whole version of the quote.
Yes, you are being struck by an accelerating Earth.
But that suggests that if you were 180 degrees away and fell off the roof, you'd fall up.
Oh, don't tell the flat earthers that. They make YouTube videos about that.
No, that's the whole version of the quote. A man falling off a roof does not feel his own weight.
Yes. Yes.
And that's the key.
Yep.
Let me ask you something. Let's say a star 1 light year away from us blew up and we got the light today. We can backdate the light to when we, relative to us, relative, it actually happened. What does that date actually mean? Let's say January 10th, 2022, it blew up.
Yep.
So like, did it really happen then?
And what do you mean by that?
I don't know.
Okay. So what we can say
Thanks.
is that today is the day that the star blew up. And it took this amount of time for that light to reach us, for that information to reach us. So we could say, if we teleported there on your year earlier, if we had done so, we would have been blown up. Now, whether that's useful?
But if you
There's
could
a
tell
comment.
Oh, there's a comment?
Yes, there's a comment that I think speaks to this, which Paul Emil says, but when the information from Betelgeuse exploding gets to us, we know it happened in the past. Seeing the event is our future, but the event is not.
See,
Yes.
this is my problem too, because you could teleport there the second the light gets to you, and you're like, oh, Betelgeuse blew up, and you could just go there immediately, which you can't. But if you could, you would not see it blow up again. You would see a year-old nebula.
Yes. So what is not affected by this is, and this might address the comment, because that's very true. And again, like I said, I'm kind of glossing over this. But what is not affected by this is causality. Causality is not affected by this. What do I mean by that? By what Paul said there. The event, the information is in our future, but the event is not. Right? So we get the information, but we can have no causal effect. We can't beam it. This is Rick with the laser beam. Right? You can only affect the things in your future light cone, and you can only be affected by the things in the future light cone of things that have occurred. The causality is not mucked with on this. So I'm going to come back and say, does that help when I talk about overlapping past and future light cones? If the causality is not messed with. If your future can't causally muck with something else's past, does that help?
Yeah, that allows it to have happened, whether we know it or not.
So
That's
time.
why it's in favor of determinism.
So time is subjective, but the order of operations is objective.
No, your marker clearly hit me first in one example, and her marker clearly hit me first in another example.
But when Rick points his laser beam at the light in the sky, he's just pointing light at light. He's not going to hit the star. The
Yeah.
star is gone.
Well, here's the important thing. I may have received that information in different orders, but think about the causal chain. Why did you throw the marker at me?
Because you told me to.
Okay. Did you throw the marker at me before I told you to?
No.
So the causality is preserved.
But that's what I mean by order of operations.
Okay, then yes.
Do it.
But if you could run a bit slower, would it have changed the past, like of each of us throwing the markers? If you had, your speed had changed somehow, you know what I mean? I'm just, like, wouldn't that have affected the past of who hit you?
If you hadn't moved.
And couldn't that change something about what was happening with each of us in the past?
So if things have been different in the past, they would be different now. That seems
Well, I think
right.
once you threw the
No, I'm
marker,
not. I'm just trying to make sure.
once you threw the marker, I don't think my motion could have retroactively affected that.
I'm just thinking of these light, what do you call them?
Light cones.
The light.
Or triangles in this case, because they're two-dimensional.
I don't know, if they're intersected with, in a different way somehow, I'm not sure how that would happen, but could that have an impact on the, I mean, I guess I'm not really on board with just the total determinist thing, but, I mean, I don't know, I just wonder about that, what we don't know, and,
Well, let's circle back to that, if I may. So do you notice that, and this always happens, you notice that the conversation is revolved almost entirely around determinism and whether it's deterministic or whether we can break the deterministic nature of it in some way? So
This is why I just checked out.
what is this,
You can't answer it.
does this What effect does this have on the concept of what we define as free will? And the free will of Kevin deciding to get up and leave the room, not me clubbing him and dragging him out of the room. So, what we consider to be real free will. What was the initial definition from earlier? Could do other? Could do other. Can could do other be saved here?
On a quantum level, yes, but you haven't officially brought that up yet.
Well, I kind of mentioned it. We don't have to be official or unofficial.
Yeah.
Sure, it can be saved.
How can it be saved?
For the causality reason. So if my future is still in someone else's past, it doesn't really make a difference because it's all over.
This feels like the Penrose stairs.
I should have said the word local more. Could you tell me more about the local?
So I have free will locally. Other people may, say, oh, this information's been traveling for 1,000,000 years, so it's predetermined, but that's not my experience. My experience is I'm still here now with a future that I can still have some agency and make choices.
That raises an interesting question. If free will does exist, where does it stop? Because you don't have dominion over everything.
Did the Zoom people hear Kevin's comment?
I don't need dominion over everything. I can pick up my life. I can use it.
Well, the other thing about free will is that, I mean, what is it really? Is it just sort of, for totally free, is just therefore sort of random? Like it's untethered from all prior causality. It's just sort of weird, random, unpredictable. But that's not what we mean, I don't think, when we talk about free will. I mean, we don't mean that we're all just running around doing random things that don't make any sense, right? So.
Yeah, if it's free will, it has to be a choice. So it could be anything, but it also has to be what you want it to be. You have to pick something.
My basic experience of the universe is that most of what we consider free will is actually heavily conditioned behavior. That is, it's been caused or at least heavily influenced by past events. And then within that, there are these sort of weird, spontaneous, random events that occur that shake that up and lead to new possibilities that aren't strictly determined.
I'm being intentionally quiet right now, so it's y'all.
Well,
Zoom
does that
people.
happen if you have a different interpretation of something that happened in the past, does that change the thing that happened in the past?
For me, it does, but
No.
I mean, I've revised my sense of the past events many times. You know, somebody hurt me,
Yeah.
and I was angry, and then I discovered why they did what they did, and I wasn't angry anymore. So, so my sense of the past, or of my past, certainly changes fairly frequently.
But doesn't that change what they did?
Does that change what
Because
they did?
you said they hurt you, but perhaps
Maybe
they were
they
just
didn't hurt me.
ignorant of something,
Yeah.
But if they hit you with a stick and you still have a scar, the fact that they just turned around fast, not knowing you were there, changes how you see it, but the scar's still there, and that, it can't not be there.
But like with this, how do I know what the past actually is other than how I've experienced it?
Because he could have turned and run into the stick, the person didn't hit.
Yeah, maybe I'm
I mean, it's
remembering it
like-
wrong.
It's
I
just
ran into
insane.
stuff.
Yeah.
I totally went doing it.
Yeah, so I've snuck in a little bit of the local Laplace's demon where I'm like, well, this is your past, and you know everything in every particle and every quantum spin and every bit of momentum and every bump, which is clearly not the case.
And every second you learn more as more stuff falls into the
Yeah, like, look, damn, all I gotta do is stand here and I'm getting way smarter.
Yeah.
So no, I mean, obviously we have an imperfect understanding, we have imperfect knowledge of all of these interactions, which is how I would put physicsy sounding language to what you've described. So I have snuck in a little bit of Laplace's demon on having perfect knowledge of our past on this, which is probably inappropriate, practically speaking.
So from where, I always get a little hung up on the vertical timeline, as to whether So that timeline is not some sort of absolute where every observer has to be in the same notch, but observers can be in different places on the timeline at the
Well, it
same
depends on how you
time?
define it. So I probably didn't spend enough time on this or do it very well. So when we did the clicking lights, and we saw that that ended up looking like it was taking different amounts of time for different observers moving at different speeds. So again, if we all try to synchronize our watches, if we're moving relatively true to each other, our watches all will tick at different rates from each other's perspective. Every one of us will look at our watch and be like, well, mine's working. Theirs is weird.
I've been told this is
But
a
they
real
will all say
problem.
the same thing.
I've been told this is a real practical problem with the satellites that control GPS.
Yes, our GPS system needs to take relativity into account, otherwise it would drift in its accuracy quite severely, actually. And even just in orbit around Earth, the effects, they're still microscopic, but they add up. You know, they're significant enough that we have to account for them with the math. We have to account for this in the math in order to have our GPS system work correctly.
So I'm still confused because like when you had our 2 or 3 observers with our flashlights, they were moving along the timeline at the same notches.
Well, remember, I'm only drawing the graph from one observer's perspective. We would have to redraw the graph from the different observer's perspective to really get that, and something I have totally not drawn is the Lorentz transformations to do that accurately. Because it's not just, you don't just go and turn the graph, because let's say the reason for that is, how do I want to do this? Let's get rid of Betelgeuse here. Let's say you have one observer who's moving at half the speed of light this way, and another observer who's moving at, let's say, 0.75 the speed of light this way. If I redraw this graph from this observer's perspective, well, isn't this observer now going faster than light?
Everything is perspective.
That doesn't work. So there's actually some complicated math, it's called the Lorentz transformation, that you don't just rotate it, you actually have to deform the graph. Because all observers will always see the speed of light as c, no matter, you know, relative speed. It's the idea of if you have a...
Plus the speed of the train that you're on.
Well, let's try
C
it out.
plus 15 or whatever.
No, let's do a car.
That's the answer to my question, though, is if free will does exist, then the dominion is the cone. You can't have, even if free will does exist and you can prove it empirically, you can't have it outside the cone.
Well, you can't affect things that you can't affect. I mean, yes. Am I misunderstanding? Is it?
No, it's a circular argument,
Okay.
but I'm drawing satisfaction from the perfect circularity of it.
Okay. Just the other example I gave on this. So let's say I'm so happy the Cybertruck is a thing because I can draw it. It's good.
It's perfect.
So let's imagine you have somebody, for some reason, on the roof of the Cybertruck shining a flashlight forward, and the Cybertruck happens to be traveling at half the speed of light. So from the perspective of the person on the Cybertruck, they shine light forward, they see the light moving forward at the speed of light, and this doesn't bother anybody, right? But let's say you have somebody over here just kind of hanging out, and they see the Cybertruck with the passenger moving at them at half the speed of light, plus the full speed of light of the flashlight, therefore they perceive the light to be arriving at them at 1.5 c, 1.5 times the speed of light, right?
Well, they don't.
But yeah, so that's what I'm getting at with the Lorentz transformation stuff. There's actually a whole lot of extra math we add into the velocity addition that we don't have time to get into. Basically, all of this scales. And so it speeds, like when you're on the highway, and you think you're doing 55 miles an hour relative to the highway, and somebody in the other lane coming the other way is doing 55 miles an hour relative to them, you can actually calculate there's a microscopic difference in your perceived speeds of each other due to relativistic effects. It's just so tiny we don't care. However, if you're going 0.9 c this way and they're going 0.9 c the other way, you will perceive some pretty massive shifts in your speeds that you're measuring relative to each other, just to make sure everybody behaves the speed limit. And it's a whole other seminar we could do on that. But we're getting almost to 9 o'clock, and Margot is giving me a much needed signal. So those of you who know more physics, I recognize I have glossed over some. There is a locality, there's a Nobel Prize that we might have to give up locality, which messes with this. But yeah, so I've glossed them over, but my goal in this is to get the gears turning a little bit. And next time you either are showing somebody a telescope or being shown something through a telescope, and they say, you're looking at this as it was, you can go, well, it depends. And you might annoy them, but that's it. So any other thoughts, comments, please?
Yeah, I have one.
Sure.
I have one question. Why is the universe on such a large scale, very deterministic. I mean, look at stellarium. You can, type in your latitude, longitude, your time, your coordinates, and the right ascension declination of any star will match exactly within, error of a few arc seconds. I mean, how is it that, it's the perfect clock? Why is it so gray and perfect like that, deterministic where other things aren't? You know what I mean? That kind of blows my mind now.
Well, one thing I would point out is to be aware of the era in history that we are living in, because we look at the planets and we know that they are something fundamentally different, which is why they move so damn weird. But there was an era in the scheme of things, fairly recent human history, where the perfect clock was like, well, except for these are different for some reason. So there's that. And secondarily, what I'll say is, my physics class, I start off with a very frustrating thing on the board, which is I say, only stuff can make stuff do stuff. And so my answer to you is those celestial bodies will keep doing what they are doing, right? Newton's first law, an object in motion remains in motion, all that good stuff. They're going to keep doing what they're doing until something else causes them to do something different. And it's somewhat difficult, despite what American Congress critter might have suggested as a solution to global warming, it's somewhat difficult to redirect planets and stars in their motions. And if any of you don't know what I'm referring to, I think it was a congressman asked the U.S. Forest Service if they could just push Earth a little bit further away from the sun to calm down climate change. Yeah. Well, at that point, there's this thing I want to do that, it's like, wait, hold on a second here. let's talk about this. So I would say the reason for that is simply because not a lot of stuff gets smacked very often on human timescales that would mess up what we see as a very consistent and predictable motion of objects.
Like a comet, for example, comes in, if part of it outgasses, then that affects its orbit, and it affects its magnitude, and then the orbits of comets aren't very predictable.
Well, also remember that the
force acting on it because there's outgassing from the nucleus, so that causes a change in the nucleus in the body, whereas Jupiter, the planets are such in a nice resonance that it's going to take something huge to disrupt that. You're right.
Yeah, I mean, remember the tail of that comet is going to gravitationally disrupt the orbits of the planets. We just don't care because it's so tiny. I mean, when we send our space probes and we do gravity assists, we alter the orbits of the planets we do gravity assists from. It's just microscopic, so we don't care.
Right.
So, I mean, Earth gains hundreds and hundreds of tons of mass per day from dust hitting us, from stuff hitting us, and we don't care because Earth is bigger. And Earth isn't all that big in the scheme of things. So that's my answer to that, is it would appear to be so on human timescales, but we are very short-lived in the cosmological terms.
Oh, yeah, that's true. All right, yeah, thank you.
Sure. Anybody else? I realize that I've intentionally left you unsatisfied.
When you say only stuff can make stuff do stuff, how would you explain the decay of a radioactive nucleus? What is the motivator there? That's the last unit I cover, which is nuclear physics and the weak nuclear force. Yeah, I want to speed run this.
Oh, God. Can I take a water first?
Because to me, in my mind, I genuinely don't know what you're going to say, because the answer to me is circular. The atom decays because it's radioactive. But that doesn't
Oh, so it's radioactive because it decays.
Yeah, exactly.
Yeah.
It's a circle.
Well, I would only do that direction, though.
What do you mean?
But I'm also less versed in that stuff. I'm weaker on that content. Do you mind if we talk about that offline after?
Oh, yeah, sure.
Okay. So, sorry, my voice is worn out. So I don't want to keep people till almost 9 o'clock. I hope you enjoyed. If you hated it, if you loved it, let me know, especially if you hated it, so that it uninflicted on anybody else. Please have some sympathy.